Alright, so let's go ahead and get started here. So we are on the bottom of page 315, example 6. Example 6, the profit P in thousands of dollars for a company spending an amount of S in thousands of dollars on advertising is P equals, and they give the equation there. Find the amount of money the company should spend on advertising in order to yield a maximum profit. So again, we're trying to maximize something. They give us an equation, so our primary equation they give us, that is P equal to negative 1/10 S cubed plus 6S squared plus 400. That's the primary equation. So what we need to do first is we only have one variable, so we need to just go ahead and take a derivative. So let's find P prime. Markers are not doing very well. Alright, so that is the derivative there, negative 3/10 S squared. Sorry. We'll try the green though. S squared plus 12S. Alright, so once we get our first derivative, we set it equal to 0, but we're also going to be able to, I'm going to do two steps at once. Set it equal to 0 and factor out an S. Alright, so now we want to go ahead and solve it and try to find out our values or critical points of what S could be. So go ahead and set both parts equal to 0 and solve for S. So if you're having trouble reading that after solving, you may have had a few more steps. I skipped a few steps in the solving, but your final answer, you should have got S equal to 40 and S equal to 0. Did we all get those two? Okay, so now we can only use one of these answers. Why can't we use both of them? Why can't both of them be our critical points? Which one would we use? Which one can't we use?
You can't use 0 because you're not spending any money.
Yeah, we're not spending any money. That's the beginning of our interval there. We're not spending anything, so we're not going to use that one. So now we can go ahead and set up our intervals. 0 to 40. And 40 to, we're going to put a question mark. We really don't know where we're going to stop. We're going to pick some value larger than 40 to test that point though. So P prime, we want to find whether positive or negative within those intervals, 0 to 40 and 40 to question mark. We're not sure where it stops. So find out if it's positive or negative within those intervals. You have an answer, Stevie?
Positive or
negative? Yes, positive, then negative. So our point of 40, does it show us it is a maximum or a minimum? Maximum, yes. So that's what we wanted. We wanted to maximize profit. Does it actually tell us to find the amount of money the company should spend in order to maximize the profit. Okay, but it doesn't ask for the profit. So it just asks for that there, the S40. So our conclusion, since P prime changes from positive to negative, profit is maximized when we spend how much? Profit is maximized when we spend how much money? Stevie?
40,000.
Yeah, it's in thousands, 40,000. When $40,000 is spent. So P prime changes positive to negative. It's maximized when $40,000 is spent. Very good. Any questions? All right, once you're done, we'll go ahead and turn to the back. Example 7. All right, example 7, they already give us a picture or diagram to look at, so that will be helpful. It says determine the point on the line y equals 2x plus 3, so they have given you that line, so that the distance between the line and the point 1, 2, they give you the point, is a minimum. So they want the distance to be a minimum. So what is our primary equation going to be? Primary equation. What was it? That's going to be our secondary one that's going to help us. Secondary. They give us the secondary y equals 2x plus 3. That will help us.
Distance formula.
Distance formula. Does anybody remember what the distance formula is? Go ahead.
The square root of y2 minus y1 in parentheses to the power of 2 plus x2 minus x1 in parentheses to the power of 2.
Yeah, I'm going to write it a little different in terms of this problem. We'll have x1 minus x2, but you had it correct, squared plus y1 minus y2. It all depends on how you plug in. I have x1 minus x2 squared plus y1 minus y2 quantity squared. Again, the order doesn't matter as long as you start with x1s or start with y, or x1 and y1 or y2 and y2, as long as you keep it the same.
Is everything square root?
Yes, sorry. There we go. Square root quantity x1 minus x2 squared plus quantity y1 minus y2 squared. I have another green marker. I'll try it and see if it's any better. Alright, so they give us a point. We're going to use this point in the distance formula. So distance equals square root. We're going to have x minus the x value of our point, which is 1, and square that, plus y minus 2, and square that. So x minus 1, y minus 2. I know it's hard to see back there. Is everybody okay so far? Alright, so now we have our secondary equation. We already have written that, so we're going to go ahead and plug that in for y. That's our next step. Plugged in. If you want to, you can just simplify that right away. That'd be 2x plus 1 instead of 2x plus 3 minus 2. That'd just be 2x plus 1. So now our next step is actually to multiply that out. We need to square both of these values. So x minus 1, square it, write out your values. This 2x plus 1, square it, and write out the values. Again, this will still all be under the square root for now. Multiply it all out. If you want to check your answers as I read this. Square root of x squared plus 2x plus 1 plus 4x squared plus 4x plus 1. Now there's some terms that we can combine together. Five x squared plus 2x plus 2. Good, Garrett? Is there something? You're good? All right. Now, we have our simplified version. So the next step is to do what? Derivative. So take the derivative of the square root of 5x squared plus 2x plus 2. Remember, square root is the power of 1/2. One half times the quantity 5x squared plus 2x plus 2 to the negative 1/2 power, 10x plus 2. So again, I'm going to set that equal to 0 and simplify at the same time. I'm left with, let's see, the 1/2. I have a 1/2 here, and I can factor a 2 out of 10x plus 2. So that's going to cancel that 2 and the 1/2. So I'd be left with 5x plus 1 on the top, because I factored out the 2. And then I'm just going to take this negative 1/2 power to the bottom. So square root of 5x squared plus 2x plus 2. And that's set equal to 0, so if we would multiply that over, it's going to disappear, so you just need to set 5x plus 1 equal to 0. And solve for x. X is equal to what? What is x equal to? Stevie? Negative 1/5. Okay, we found the x value. We need to make sure that that will minimize. So again, create your table. Negative infinity to negative 1/5, because we're checking x values. It can be any x value on this line, and this line is going to continue on, so that's why we're starting at negative infinity. And then negative 1/5 to positive infinity, because it can be anywhere on the line. Check your signs for the derivative, positive or negative within those intervals. Anybody find positive or negative? Determine which intervals. Negative, then positive. So it does confirm that it would minimize. So now we have an x value. Let's find the y value. So I got y equal to 13 over 5. So that is telling me that my point, which would minimize the distance, would be at negative 1/5 and then 13 over 5, so almost 3. So it's going to be somewhere in that vicinity right there is where that would be. So our final conclusion is going to be D has a minimum at x equals negative 1/5. So the distance has a minimum at x equals negative 1/5 because D prime goes from negative to positive. And again, make sure you either circle your x and y values or put it together as an ordered pair. Negative 1/5, comma 13/5. Make sure that answer is shown. Has a minimum because D prime goes negative to positive. Alright, any questions? I know some of that's hard to read up there with the color, but yeah. Yeah, I'm trying. The ones with the darker color are not writing as well. I'll try it though, and we'll see how we do. Yep. Alright, any questions on that problem? Anything you missed with not being able to read it? Okay. Alright, let's go ahead to example 8 then. A rectangle ABCD, so this rectangle in here, with sides parallel to the coordinate axes, so parallel to the x and y axis, inscribed in the region enclosed by the graph of negative 4x squared plus 4. So it's enclosed by this upside down parabola. Find the x and y coordinates of the point C so that the area of the rectangle is maximized. So what we're going to do, we're going to call this distance from here to here, we're going to call that distance x. And we're going to call that distance from here to here distance y. And our point, our answer, is going to be some point x comma y, that point C. So what is our primary equation?
1a equals xy because that's the area.
Okay, we want to maximize area. How am I going to find the area of this rectangle?
2x.
Yeah, I have an x here and an x here because this is only half of it. So it's going to be 2x. The whole thing is 2x times y. Good. And I have two variables, so I need that secondary equation, and they give that to you right here. Negative 4x squared plus 4. Go ahead and plug that into your original. A equals 2x times negative 4x squared plus 4. And again, start through that simplification process before we take the derivative, because right now we would have to do the product rule, and we don't want to do that. We want to make it as easy as we can. So before I take the derivative, I got negative 8x cubed plus 8x. Everyone okay so far? Alright, go ahead and take the derivative. And then once you take your derivative, set it equal to 0 and solve. Did we all get the same value for our x? 1 over the square root of 3. Now, you may have gotten square root of 1/3. Well, you can have the square root of the top over the square root of the bottom, so square root of 1. That's why I just have 1 over square root of 3. It's the same answer if you left it like that. So now we have our interval. Again, this is a side length, so we're going to start at 0, comma 1 over square root of 3. And we don't know how big the side length is going to be, so we'll say infinity. Check the interval for positive and negative. Any luck out there? Anybody find the intervals? That is what I got. Positive, then negative. So indeed, it does maximize the equation. So we found the x. Now we need to find our y value. So we have a y equation. We can go ahead and plug it back in. Y equals negative 4 times 1 over the square root of 3. And that quantity is squared plus 4. Should be able to find your y value. And again, we found the x and y that maximizes it. That's that point C. We just need to state our conclusion. Since a prime changes positive to negative, a has a max at x equals 1 over the square root of 3. Then again, make sure your x and y answers are circled, and then you could write the coordinate pair 1 over the square root of 3, comma 8/3. That's your final answer. They wanted that point, so you can write your coordinate pair. And that is the last example for the optimization. Do we have any general questions or anything about this problem?